pizza. Hi, how's the pizza? Good? Nice. My name's Dan, so it's a pleasure to be here. Thank you for the Hasura team for setting up this event today and providing the pizza. It's a real pleasure to be here. And thank you to all of you for coming here as well and showing up. So about myself, I was a contributor to a couple of libraries that you may know. One of them I'm going to be diving into today, which is the Neo4j GraphQL library. And then I was also a core contributor to Prisma, the ORM. Outside of that, I founded a company called rconnect or rconnect, and I'll dive into a little bit more about that at the end of this talk. I'm from the UK, as you can probably tell from my accent. I like tea, travel, software, community, and things like that. As I said, my company is called rconnect, so I'll just briefly go over this, but you can find us more at rconnect.tech. And you would have seen myself or some of the team at some community meetups like this around the globe. So the agenda for today is that I'm going to dive into a library called Neo4j GraphQL. So Neo4j is a graph database, and of course, Praveen just told us all about GraphQL, so thank you so much. And we're going to dive into how to use the Neo4j GraphQL driver, and then use the driver and GraphQL together in a Node.js stack. So there's going to be a bit of code in here, but I've put most of it on the screen, and just shout at me if I'm like doing too much code. So graph databases, is anybody working with graph databases at the moment? Or you are? Okay. Anybody? One? Okay. Or anybody heard of graph databases before? Okay, a few of you. Great. And who hasn't heard of graph databases or hasn't worked with them at all? Okay, great. So they have like a bunch of these superpowers that I won't go over again. But for the most part, we need to think about graph databases in how we think about our data. A bunch of graph databases out there. I'm going to be diving into Neo4j. It's highly optimized, has the Cypher query language, and you can go and check out the website to find out more specifically about Neo4j. Okay, so thinking about graph databases. Kanye Reeves acted in the Matrix in the year 1999. So if you're thinking in a relational world, right, you might make a table, the person's table, the people table, insert a row, Kanye Reeves, and then you'll have like a movie table, and you'll add the matrix in. It's all straightforward so far, but then when you start to add the relationships into your data, you have these weird things in the middle, which are called joint tables. And when you use join tables, you then end up having to traverse that data using something like this, which is double join statement. It's a nasty SQL statement, and who here has written anything like this before? Okay, great. So it's not really how you think about your data. You don't think about your data in terms of like tables, rows, columns, and things like that. Instead, if you was with your team, and you was on a whiteboard, maybe over here on the whiteboard, and you started drawing out your data, you'd probably get a pen, and then you'd probably write, you have movies, and then you have people, and then you would join, you'd maybe make an arrow between those, and then maybe one of these whiteboards over here would be filled with loads of nodes and arrows or relationships between them. And so that's exactly how we think about our data when using a graph database. We have nodes which have labels and properties, and relationships which also have labels and properties as well. So you can see the difference where instead of using a join table, the relationship is fundamentally stored differently and treated as a first-class citizen in the database. So you can completely forget the concept of foreign key or joining, and instead I'll show you using the Cypher query language, how you can traverse between nodes. So Cypher. Cypher is the query language that Neo4j, the database, uses, and it's designed on pattern matching. And so you'll see that we're looking for all of the movies with the name, all of the persons with the name of Kanye Reeves. And so we use this bracket syntax to almost represent a node in a circle, and then we're given the variable p of what we're matching, and then the label is person. And so this is just matching one node. But of course, in a graph, you want to be able to traverse those relationships. And so what we can use is pattern matching in the Cypher query language and essentially traverse that relationship that we have called acted in, and then pick up or collect all of the movies under the variable m, and then return them. So this is going to find all of the movies that Kanye Reeves acted in and then return them to us. And you can actually do that in one line. So I was just trying to explain that for you, but most likely you're going to be doing this in one line, and it's quite expressive compared to the 3-4 line SQL statement that I showed you just a minute ago. So just to recap so far, we've gone over just a brief intro to graph databases, and I've just dived very briefly onto Cypher, the query language. Does anybody have any questions? Okay, cool. So Neo4j desktop. So I imagine most of you are developers here, and you probably want to get started with Neo4j after this talk. I hope so, fingers crossed. I get referrals for the amount of downloads that you do. You can do it by using Neo4j desktop. So I have it downloaded at the bottom here. It's free to download, so you can just go to neo4j.com, download the desktop. It'll work on Mac, Windows, whatever. And you can start a database. So I'm just going to start one where it's already started. And then when I open it, this is going to give me, let me get rid of that. This is going to give me what's called Neo4j browser. So this is spawned from my database that's running locally. And essentially, you can think of this as like, a SQL workbench, but for your graph database. So as a developer, I'll come in here and start iterating on queries and exploring my data. So let's just do like a simple match, and let's match all of the nodes, no matter what the label is. And let's just return, and we'll call this n for nodes. So this is just the variable that we want to collect them with. And I run that. And I've populated some movie data, which comes from Neo4j browser in here. And you can see that you can start to visualize and explore your data a lot easier than, say, if it was tables and columns. We have more real estate here because there's just lines versus an extra join table. Neo4j does have a dedicated tool called Blue, which you can explore visually large data sets. This is, of course, just used for local development, and it's also just kind of fun to just like wiggle the mouse around a little bit. But if we take that query again, for example, where is it? We match Kanye Reeves and all the movies that they acted in, and we'll put that in there. And you'll see here that now it's given us all of the movies that Kanye Reeves acted in. So it's quite simple and fast and efficient to traverse these relationships. Great. So we've touched over a little bit about what graph databases are. We've talked about Cypher, the query language. We've explored Neo4j desktop, so you're all ready to get started locally. Now let's see how we can merge them together and build a GraphQL API using all of what we've learned so far. So as Praveen already told us, we can start with a few approaches to building our API. So here is a schema-first approach where we defined the type definitions, and then we back those type definitions with resolvers. So this is just a hard-coded API, nothing out of the ordinary here. And then if we queried that API, we would basically ask for the movies when we would get the one hard-coded value back. Nothing out of the ordinary here. Let's now add the Neo4j driver on top of that and then see how we can start to use that in a resolver. So Neo4j driver is available in many languages. For the purposes of this talk, I'm just using TypeScript and Node to keep things simple. And it's quite straightforward. You import the driver from the npm library, and then you construct it, pointing it to localhost or wherever. This is my production database, so if you want to screenshot that, then. And then you can construct spawn a session. It's transactional, and then you can hit a query. So this is just going to give us a JSON list of all of the movies that are in the database. So now you might be thinking, okay, we know, if we go back 2 slides, a couple of slides, we know how to build resolvers, we know how to construct a driver. So surely the next best thing then would be to, spawn a session inside of our resolver, and then manually write the query out. And this is a pretty good start. If you have a bunch of resolvers and you want to talk to Neo4j, the database, great start. And you're probably going to need this if you have custom business logic or if you're in a really complex application. However, this can be quite cumbersome. Neo4j doesn't have a schema itself, and so you're relying on your other developers or communication in the team to make sure that these queries here are selecting the correct fields, labels, and properties. Not only that, if you want to get started very quickly with Neo4j and GraphQL, then this is probably not the best approach, because you're going to have to understand Cypher, the query language. You're going to have to start a database locally and build all of your resolvers yourself. So Neo4j came up with a solution, and this is called the Neo4j GraphQL library. And essentially, it removes the need for you to write resolvers in your code. So I'll show you in a moment. You can basically define some type definitions, pass this into the engine, and then it will automatically generate a fully functional API for you on top of Neo4j. So if we take a look at our whiteboard model here of our movies and people, we can express this using the GraphQL schema definition language by having just standard key value pairs for the title and released, but then using special GraphQL and directives, as you can see on the relationship, to specify the underlying relationship that's going to be stored in the database. And once we've defined these type definitions, which we can just declare them as type defs in our code, we can then use about 30 lines of boilerplate code essentially to construct a Neo4j GraphQL instance and then pass the type definitions in there. And that's the only input essentially that you give to the Neo4j GraphQL library. There's no resolvers here at this point. And you can start your server, yada, yada, yada. And let me show you a live demo of that. So
your types are edges, basically, right?
Say that again, sorry.
Your types are edges?
Types, I'll show you what is edges. These are the relationships, the edges that get annotated in the type definitions.
Okay, yeah, right. Yeah. So your Neo4j, your edges would be your GraphQL types.
Yes. Yeah, because Neo4j by itself is schemaless.
Yeah.
And so for the application layer, this is a great library to use because you can leverage the GraphQL schema as essentially your database schema. Okay, so here's the example blown up a little bit. So we have our type definitions. I'm just going to add a couple more properties on there, which is released. And person was born as an integer as well. So this is essentially my Neo4j schema. And then we have a driver. And then, within 40 lines of code, we set up the schema, construct the Neo4j GraphQL instance, and then we just pass it into GraphQL Yoga. This could be Apollo server or any other JavaScript runtime that will run your server. And I'll start that. Remembering that the only input that we pretty much gave it was these type definitions. And here we have a GraphQL API. And you'll see that we have in the Schema Explorer, we have a bunch of queries that have been generated for us. So like a generic movies, read. We support relay pagination connections. So you have movies connection there, which you can do cursor-based pagination. Aggregation, so for example, you can find out find me the longest movie title, and so on and so forth. So for each type you declare in your type definitions, the library is going to generate for you a read one, a connection one, an aggregate one, so on and so forth. And excuse me, and the same for mutations as well. So you have a bunch of CRUD operations that you can do. So let's start querying. So let's say we want to query for, all of the movies where the title contains matrix. I'll just get rid of that. The title, maybe it's case sensitive. Okay, it's case sensitive. So we found all of our movies, and that's generated for us the efficient Cypher query under the hood to resolve that. But the real power in this is traversing relationships. So in the GraphQL schema, we annotated it with a directive, which you mentioned is the edges. These are now reflected into the generated GraphQL schema. So I can ask for all the movies where the title contains matrix, and then also give me all of the actors for all of those movies, and then resolve them for me as well. And so I haven't had to write a single Cypher statement or a single database query, and all of this has been generated under the hood. And just
Can you see the Cypher query though?
yes, I'll put debug on and show you it now. So let me run email. I run the same server, but with debug on star. Okay. And then I'll run that again. And you'll see highlighted here. So we asked for the movies where the title contains matrix. So you can see here that it's matching the movie, and then it's appending the where clause there. And then it's doing a subquery, and then it's doing some pattern matching on the relationship, which we annotated in the schema, and then collecting it all together in an JSON object. So it's not the most readable Cypher that you'll see, or maybe not the most efficient, but it's a balance between time to market and developer productivity versus efficiency. Neo4j GraphQL also has escape hatches, so you can add your own custom resolvers into the schema, or you can inject things into the generated query, or override the generated query completely, depending on your efficiency needs. But for most full stack applications, a query like this is completely fine, and it's going to be negligible for performance.
Is there a way to go the other way? If I wrote a Cypher query, could I turn that into a GraphQL query?
You can indeed, yes. So there's an annotation called the Cypher directive, a little bit like the relationship directive that I just used a moment ago. And this will basically inject Cypher into the GraphQL query that's generated for you. In fact, maybe we can manually try this out. I'm not sure, it's been a while since I've done it. So we'll ask for the movies, and instead of having the actors auto-generated for us, we can use, AI's done it for me. Great. There's me nerve-wracking typing, thinking, yeah, so basically we can inject this SQL statement, Cypher statement into the runtime, and it will basically be doing the exact same as what it would be above there. And this is great if you want to do like analytics, because the library is going to just generate for you basic CRUD and some aggregations and things like that. But maybe you want to do something very specific, and this is where you should do it.
Or if I feel I can fine-tune Cypher better than the engine could.
It's the best place to fine-tune, yeah. It's best to maybe use the library to scaffold your application, and then you can sort of fine-tune it with these Cypher statements and lock things down. It also has like auth built in, and you can turn off certain filters. Everything's available at first, and then you can sort of tune it down to how you need it. Go ahead.
How do you set the authorization layer?
Sure. So the authorization layer depends on the context of GraphQL. So I think it's in here in Yoga, you have the context, and you basically inject the request, the headers, into the context. Yeah. And then Neo4j GraphQL has a bunch of directives. So you can say like, auth, something like that. And you can like pluck out values of the JWT and then use it as a predicate for the field or the type that you're querying or editing. And one last thing I want to show you as well is because we've mostly touched upon reading, but writing can be quite powerful through Neo4j GraphQL because we have something called nested mutations. So, I can make a, let's create me, right? So let me put myself in there, named Dan. And I was born in 1999. If anybody knows that age, let me know. And we'll just ask for the people back name. So I can create that, and obviously that's just going to do like insert one node into the database, pretty straightforward. But with a graph, you can basically build like a whole pattern in one go, which is really, really handy. So we're going to do this via the nested mutations. Let me prettify this. I'm going to say create Dan, and also let's add a movie. Let's create a movie at the same time. I'll just prettify this, and let's say that the title of the movie, that it gets a bit long, but I'm trying to format it for you. The title is Dan in SF. There we go. So it's a little bit long with the formatting from GraphQL, but this is going to essentially create two nodes in the database for us and a relationship between them. Let me see if that done something. There we go. So it created people Dan. And if you have a look at the generated, now it gets a little bit complicated with creates, as you can see with the auto-generated queries. But if we actually go to our database now, and we say match the person, the name of Dan, P. Oh, what happened? P. There I am. But then maybe I also want to find all of the movies that I acted in as well. So I can say Dan's movies. Dan's movies. Dan in SF. So there's one movie in there. So that node, that whole graph of Dan acted in, Dan in SF was built via a JSON input from the GraphQL API. And you can basically keep on going all the way down the tree with these nested mutations. So it's super handy. If you have like a nested JSON structure, you can just sort of throw it as an argument, and then it will build a whole graph for you. Any questions?
If I'm not using GraphQL, how do I typically talk to a Neo4j database?
Sure. So they have a couple of connections. One is most common is their Bolt connection, and you would just use a driver in any of the standard languages. So Java, Go, JavaScript. There's drivers in all of those languages, and it would be part of your application stack. So very, very similar to how you would be querying Postgres or MySQL or any other way. You're just swapping out the driver essentially. If you go back to this slide, where are we? Driver. Here. So this is how you would talk to Neo4j just using standard node. this is how the Neo4j GraphQL library also talks to Neo4j behind the scenes. And there's very similar ways of doing it in any other language that you might choose. Mm-hmm. Yeah, do you want me, I can show you. Yeah. Yeah, so another one would be, so the question was, can you do other relationships other than acted in? Which is a fair point because I've only showed you a very small graph. People act in movies is quite straightforward. But maybe another one, for example, would be a movie is in a genre, and that genre is horror as well. And so I'm not sure if the demo database has it, but let's just find out. Let's match all of the, I'll tell you what, let's match all of the movies. No, it just has movies and persons, but we can create it now. So we can say match the movie matrix. And then what we're going to use is, so we've found the matrix and we want to like build a new relationship in the graph of the genre of this movie. So we can use the merge statement, which is going to basically draw a new line in our graph for us. And the reason why you use merge over create is because we don't want to create the movie again. So we want to merge this pattern, and we want to say that the movie is in a genre. And because Neo4j is schemaless, we can just write this on the fly. We're not relying on any schema. The schema lives in our application layer from Neo4j GraphQL library. So I can just say genre, and I can say like type is action. Okay, so it created one node, one relationship for us. So now I can ask for the matrix again. So match the matrix, and let's just return that. Here we go. And I believe now I can expand this out. Okay, here you go. So we have all of the acted in. Oh, we have produced as well, which is a different relationship, but you'll see now that the matrix is also in the genre of action as well. So you can have like as many of these relationships as you want, pointing in different ways, and they can store data on them. They can be labeled however you want. Typically, they go in this format of like in genre or acted in, because that's how you would say it. Like a person acted in a movie, or this movie is of this genre. So you try and model your graph in how you would speak about it. Mm-hmm. So specifically around deduplication, or?
Yeah, well, I'm just curious, like in the case of like genres, it seems like it's pretty easy to just create new genres and new relationships out of nowhere,
Mm-hmm.
which also makes it easy to like have a lot of duplicate genres
Mm-hmm.
and relationships out of thin air.
Yeah. So I'll believe that this is to do with the merge statement, which I just used. Where did we use the merge statement? In here. So there's two. Let me get the query up again wherever it's gone. Anybody know where it's gone? Okay. So I'll go back to what I want. Merge. Movie. In genre. title. What is it? So you'll see here, this is the query that I just ran to get this genre into the database, and I used the merge statement. And so what the merge statement will do to what you're saying here about deduplication and easily being able to create nodes is the merge will first check if those nodes are there in the database, and if they are there, then it's not going to duplicate it again. Whereas if I use like the create statement, then in this case, I'm going to be creating a new matrix movie and a new genre node. But because I've already inserted both of those, it's going to be intelligent enough to know, okay, you've already got a genre action node and you've already got a matrix node. So I'm not going to do anything. It's just going to be like a null void operation. So it's generally preferred to always use the merge statement when you're creating relationships and nodes in Neo4j. And it helps with like transactions and things like that as well. And to your point around like overall performance and stuff like that, I'm probably not the best person to ask. So I'll just pile that off to the experts. There is Neo4j people here as well. So, well. Any other questions? What was you? Oh, sorry. Yeah.
So I don't remember. Neo4j has like string-oriented. Anyway, are there ways of getting Neo4j specific functions in the GraphQL? So like, I think there's like a begins with or whatever function to like see anything that begins with at or whatever.
I see what you mean.
Yeah.
So the generated API pretty much comes with like all of the standard things that you can think of, right? So title contains, ends with, start with. All of the fields have like regex. If they're numbers, they have like max min. Basically, just the ORM standard stuff that you can expect.
Cool. Yeah, and that's translated into.
It's translated into the Neo4j equivalent. Yep. Go ahead.
Following up on the authentication question, with a REST API, it's pretty easy to lock down a specific endpoint or something like that. With this being so flexible, you can do it from anywhere and traverse the graph in a lot of different directions.
Mm-hmm.
Is it possible to lock down a portion of the graph without locking down the entire thing? In other words, with a DWT, you could protect the queries, but would it be possible to say, I want to give access to the active database, but not the genres database, or the genre side of it?
Yeah. So the authentication directive, you can put that on both types and fields. So you can say, for example, on the user type, make sure that only the corresponding JWT ID can view that user, or admins with the role. But you can also do that on, if I go to the schema, you can also do it on the query type. So you can say like extend type query, and then you can give it some auth rules. So you can do like a global read operation. So this auth directive can go here, it can go here, it can go here. It can go pretty much anywhere you want to put it. No problem.
I know Neo4j is supporting vector database queries, RAG.
Yep.
Right? I'm curious if anybody has looked at somehow augmenting GraphQL to support that type of vector database queries.
I don't know how to answer your question. Yeah.
I'm just curious if I know that Neo4j supports this idea of doing vector database queries, like similarity, or Euclidean distance between an English-based query, right? Go out and find me the relevant documents, right, or the relevant passages within a document that match my English query.
Yep.
And I know that Neo4j is supporting that implementation. I've been to a few Neo4j meetups, right? But I'm curious if I could somehow combine GraphQL to together to help facilitate that? Or do I just use Cypher instead?
Do you want to turn like an English sentence into a database query? Is that what you're trying to achieve?
I can imagine there's a layer between the English sentence,
Yep.
right? Somehow turns that into a Cypher query.
Mm-hmm.
So GraphQL is somehow involved in making the actual query itself.
It would definitely be possible. So us at rconnect, we actually built a tool called GraphQL AI, where basically you give the AI the schema as context. So the AI already has all the context, right? So then at that point you can say, well, here's my login, here's like my login schema, whatever, my auth schema. Find me like all the logins by Dan in the last day. And then given that's the context, AI has enough already to facilitate that query and it will generate that for you. So that's like a start. So if you go to graphqlai.com, you'll be able to find that out. And I'm pretty sure Neo4j does have something built in text to cipher.
Yeah. But for
Yeah.
the lines of directing to the vector database. We need GraphQL AI, then the database is the code.
But you can store the vectors. You can store the tokens in Neo4j.
Yes. So there is a vector database as part of the function. So it's more of a store.
But I guess is the user expected to do the embeddings themselves, or are you doing the embeddings on the back end?
So my understanding is that the embeddings are usually generated from like whatever other embedded engines, but Neo4j stores them.
Okay, yeah. So then I think what you would do is make an object, and then on the back end do the embeddings, and then do the query that
You chunk the document,
Yes.
right? And then you attach the vector to the node, right, associated with that document in Neo4j, right?
So we just released months ago the new graph builder, and it does exactly that. So it will ingest data from different sources and create that graph with chunks and elements.
Is it called the data importer?
No, it's called graph builder. If you type it up, go to the lens.
This one. Oh yeah, Lemon
Yes,
Knowledge
that's
Graph
exactly
Builder.
it.
Yeah. Okay,
Yes.
great. Is that everything? Okay.
Yeah, just curious if anybody's looking at that. But
Thank you for your questions. Any other questions? Okay, go ahead.
How's the debuggability? Like, cause I think that because all the kind of magic is behind the scenes. So like, if the function it has like the code that actually is very little, so then like, how do I see if there's weird behavior in debug code?
So the only way would be to debug it in the console. That's really, because most of this is auto-generated code. So the debug output will give you like everything you need to report an issue on the Neo4j GraphQL open source lib. Because you're not really in control of the code that's being executed, there's nothing really there for you to debug other than essentially give the stack trace to the team with your type depths and your query. So that's kind of a catch-22 there for sure. Yeah. Okay. There we go. So how does Neo4j GraphQL work under the hood? Here's a big diagram which you don't have to go over, but the one thing you need to remember is the type definitions, right? So we just pass in the type definitions to the engine, and then the engine spits out a bunch of resolvers for us that we can use. And it does this using what's called the resolve info. So It's particularly in JavaScript runtimes for GraphQL. The fourth argument to your resolver is called the resolve info. And it basically looks like this. This is like a really short, condensed version of it. But it will give you where you are in the tree and all of the paths below you and all of the paths above you. So with all of this information, which is a much larger object, Neo4j GraphQL reflects this resolve info into a Cypher database query. It looks something like this. So you take the resolve info, then you have like a template string, and then you iterate over all of the keys of that large object, the AST, and then you build some kind of database query. So you could do all of this by yourself, and this is just to highlight exactly what it's doing under the hood. So Neo4j GraphQL, for every operation that it generates, it just generates one resolver, and then everything gets generated from the root, from the resolve info, and then executed into the driver, and then sanitized, and then sent back through the GraphQL layer. Okay, so we've gone over Neo4j, we've gone over a little bit about graph databases, how to use Neo4j with GraphQL, and then how to use Neo4j GraphQL to auto-generate your Neo4j backed GraphQL APIs. They have a contest, Neo4j, so you can speak to Yond afterwards. They're going to give away a drone, so that's pretty cool if you want a drone. Just scan this. Okay. Okay, thank you everyone for listening.